to go over chapter 1 today. It's going to be experimental research and correlational research. And I want to give you some kind of simplistic examples to really help you understand the concepts connected to both of these types of research. So in experimental research, it's always going to start out with a hypothesis. And a hypothesis is simply an educated guess. The researcher has to say what they think they're going to see and make a guess about that. So we're starting off today with a hypothesis: watching TV violence causes an increase in children's aggression. All right, so that's what the researcher is guessing that they will find out. Now, in terms of doing this research, what age children? Let's look at maybe 5-year-olds. So let's look at 5-year-olds in Wake County. And we're going to send out a notice to parents of kindergartners in Wake County. And we got sent back 261 said they would participate, but we only need 100. We only need 100 of those individuals. So how do we figure out which 100 we take out of that 261? Well, we have to do it randomly. We can't do the first 100 that signed up. We can't do it by our favorite names. It has to be either generated randomly from a computer or some other format. So we just need 100 participants in the research. Okay, so participants in the research. Now, when we're talking about the population of a research project, what is the population? The population is who do you draw your participants from? And you're going to draw your participants from, in this study, 5-year-olds from Wake County. So that's going to be your population. Now, from the population, we draw the random sample. And the random sample is going to be the individuals who are actually in your study. Please make sure that you know the difference between population, who you draw your participants from, and your random sample, who is going to be the individuals that are actually participating in your research. All right. So let's look over here. So this is going to be your random sample. Now, what's the difference between experimental group and control group? You always want to look up to the hypothesis. And whatever the hypothesis states is what the experimental group is going to have happen. So, watching TV violence causes an increase in children's aggression. You know that particular group is going to be watching the TV violence. And you also know that the control group is not going to get the TV violence. So they're going to watch non-violent TV. So whenever you want to figure out which is the experimental group, it is going to be the group that is getting whatever that hypothesis is reporting. So we've got the experimental group of children who are going to be watching TV violence, and then the control group is going to be watching TV that doesn't have any violence. You could also have more control groups where they maybe do an art project or do something else, but we're going to keep it simple. So what would be a TV show that has some level of physical aggression or verbal aggression that 5-year-olds might watch? So maybe something like Ninja Turtles. Maybe we'll have them watch Ninja Turtles. And maybe for the non-violent, maybe we'll do Sesame Street. And it would have to be very specific. What show, which episode, how long we're going to have them watch it. Maybe let's have them watch it for 30 minutes. So you got your Ninja Turtles, going to have some, action in there. And your Sesame Street, no aggression whatsoever demonstrated. And they're going to watch that for 30 minutes. Now, how do I figure out from my random sample? I want 50 in each group. How do I figure out who goes in which group? Do I ask the parents what group would you like your child to be in? No, we cannot do that. It has to be, again, random. They cannot choose. Now, in this particular instance, probably not a big deal which group your child's going to be in. But for example, when they do research on cancer medications and the people coming into the studies don't get to say, I want to be in the one who gets the medicine for the cancer. I do not want to be in the control group. It's got to be random for the ethics of the research. So, random assignment is how we determine who goes into the experimental or the control group. So we are going to use random assignment to put 50 children in this group and 50 children in that group. Random assignment, vitally important for the ethics of experimental research. Now, after we've got the children in the groups, they're going to watch these TV shows. Let's send them out to the playground. We're going to send them out to the playground and see what happens out there. We're going to have researchers watching them, counting numbers of aggressive behaviors that they're demonstrating. And let's say we've got 15 aggressive behaviors that we're seeing out here in a 30-minute time outside, and maybe 3 over here. We're going to have to do some statistics to see if that's actually going to be statistically significant in terms of that difference. Now, looking at our research, it looks like we may have found something. Possibly. Going to need to do some statistics to find out. What I want you to understand about now is the difference between independent variable and a dependent variable. The independent variable in research is always what the researcher manipulates or creates, what they set up. And so in this experiment, I set up my groups, I set up how many, I set up what they're going to watch. So that's my independent variable. It is what the researcher manipulates. Now, and then I have them come out into the playground, but we're just measuring behaviors down here. So what we measure at the end of the study is always going to be your dependent variable. What you measure at end of study is always going to be your dependent variable. And I have posted a worksheet in this lesson that you can work with that'll give you more practice in identifying independent variables and dependent variables. And on your test, I'll give you a research example and I'll ask you to identify the experimental group, the control group, the IV, the DV. So it's something you want to become comfortable being able to do. Now, with this particular study, in order for people reading the research to really understand, if other researchers are going to be looking at this research and they want to replicate it, they have to know exactly what was done. So in order for that to happen, researchers have to operationally define each of their terms. And in our hypothesis, we had to actually define 3 different terms in our hypothesis so that it could be replicated. One was children. So what we decided to do in this research is we chose 5-year-old children in kindergarten. So that is the first operationally defined aspect of our hypothesis. The second part that we defined was TV violence. We determined as a researcher what we saw as TV violence. And in this case, we're going to do the Ninja Turtle episode. And what TV nonviolence was, Sesame Street. So those are 2 variables. The third, you've probably already guessed, is aggression. What does aggression mean? So the researcher is going to have to define aggression may mean hitting, kicking, hair pulling, and be very specific so that the researchers who are collecting the data out on the playground know exactly what is defined as aggression in this research so that they are collecting data appropriately. So you always need to operationally define your variables so that people understand how you did your research, and also research can be replicated. All right, so experimental research is actually the method that gives us the strongest results in terms of being able to say cause and effect. Because we hold things constant and one group gets one thing and the other group doesn't, we can say cause and effect with our research, what we learned at the end of our research. For example, if we were doing research on headache medicine and we used one brand versus a generic or things like that, if one brand showed a much higher level of headache reduction, we could say this medicine as compared to this other increased probability that you're going to get headache relief. So you can say cause and effect. But the other four methods of research we're going to be talking about, you cannot. So if you can do experimental research, it's going to be the way to go because it's going to give you strength in your results with cause and effect. Now, let's say, for example, that I'm wanting to understand the impact of a woman who is pregnant and she's using cocaine. I want to understand how that child, that baby's going to be impacted when they're born. Could I do experimental research? Could I have, one group of women and say, please use the cocaine, please don't use the cocaine? Of course not. It'd be unethical. You can never run research where you put anybody in danger like that. So you're collecting data after the fact, after somebody has made a decision to use. Now, you're looking at the impact of cocaine and baby's functioning. And those are two variables that you'd like to understand. So whenever we're trying to look at the relationship between two variables, we are going to do correlational research. Now, correlational research, several things that I'd like for you to know about correlation. Look at here, correlation. So the relationship between two variables. I want you to understand the difference between a positive correlation and a negative correlation. So when you have two variables and we're looking at the temperature and ice cream sales. So we know that as the temperature gets hotter outside, ice cream sales increase. We know that as the temperature gets colder outside, ice cream sales tend to decrease. So when we see the variables go in the same direction together, they create a scatter plot that has a positive slope. The slope goes up. And that's all it means. Positive and negative do not mean good or bad here. It means the scatter plot, does the slope go up or does the slope go down? That's simply all it means. It's not good or bad, better than one or the other. So, ice cream sales go up, temperature goes up, definitely a positive correlation. So let's look at grades and hours of study. So the longer that you study, hopefully, the higher your grades. There could be times when you don't get a lot of time to study. It could definitely negatively impact your grades. So we're going to see, again, a positive slope on that scatter plot. Now, what about if we were to take a look at a scatter plot like this one here? Now you have SAT scores and body size. Do you see any slope direction at all? So sometimes when we're doing research and we're looking at the correlation between two variables, we might see absolutely no correlation whatsoever. And we call that a zero correlation. So we do have no correlation whatsoever, very weak correlation. Now, here's how we would read correlation coefficients. So they go from -1 to +1. Let me, before I do that, show you what a negative correlation looks like. So a negative correlation, let's look at TV watching and grades. So the more hours you spend watching TV can definitely have a negative impact on your grades. Also, exercise and body fat. So the more hours you're putting into exercise, probably the lower your body fat's going to be. So those variables are going in two different directions. And that is going to create a negative slope, downward slope, which will be a negative slope. So when the variables go opposite of one another, you will see a negative correlation. So please make sure you know the difference between a positive correlation when the variables travel up or down together versus a negative correlation. When one increases, such as TV watching, grades tend to decrease. That would be a negative correlation. All right, so looking back up here, we have positive correlation. We have negative correlation. We have absolutely zero correlation. So let's look about how we read this with correlational coefficients. You have -1 and +1. -1 is going to be your negative correlations. +1 is going to be your positive correlation. 0 in the middle is going to be no correlation whatsoever. So if you find a correlation, can you say cause and effect? Can you say that, let's say you found a correlation that the babies who had been impacted by cocaine in utero did show a difference from the babies who were not impacted by cocaine in utero. Can you say that that difference is only about the cocaine use? And that's where it's really important to know that with correlational research, you can never say causation. You can never say causation with correlational research. You did not do experimental research and hold things constant. So, for example, with the babies who are exposed to cocaine, that difference that was found could also be impacted by alcohol use, other drugs. There could be genetic impacts. There could be malnutrition. There could be a number of things that are involved in finding that correlation. Can you report the data as there appears to be an impact? You absolutely can. Can you say it's the cause of that impact? No, you can't. So make sure that you know with the experimental research you can say cause and effect. And with correlational research, looking at how two variables are correlated, positively, negatively, or 0, you cannot say it is the cause of. No causation with correlational research. So I hope these examples have given you some more understanding of these two methods of research. You will be, in your work this week, continuing to learn about naturalistic observation. You're going to be learning about case studies and survey research as well. So I hope this is helpful, and take care.